6th grade, Module 5, Lesson 18, problem set. Calculate the surface area of each figure below. Figures are not drawn to scale. All right, so I'm going to start by writing out the formula that we practiced in the classwork. So we're going to do two groups of the length times the width. So that would be the base. And the top here, so the two bases, plus two groups of, then we can do the front faces and the back face if you want. So the front face and the back face, length times height, plus two groups of the sides. So these side pieces, two groups of those, which is width times height. All right, so let's get rid of this. Okay, so let's start with length times width. So find the area of the bottom base and the top base. So two groups of 15 inches by 15 inches plus two groups of, now let's do the top and bottom length. Oh, we already did the front face. Let's do the front and back face. 15 by 7 plus two groups of the sides are 7 by 15. So 15 times 15 is 225. Remember, we still have two groups of those, so that's just one face, but there are two of them. All right, two groups of 15 times 7. 5 times 7 is 35, carry the 3, 7 times 1 is 7, plus 3, so that's 2 times 105, and then it was 7 times 15 is 105. So 2 times 225 would be 450 inches squared, plus 2 times 105. 2 times 100 is 200, so 2 times 105 would be 210. And then another 210. So let's add those together. So 450. 210 plus 210 would be 410. So we get, 210 plus 210 would be 420. So we get 870 inches squared. Okay, let's do the next one. So two groups of, let's find the top and bottom bases. So the length is 18 and 7/10, and the width is 2 and 3/10. Plus two groups of, let's do the front and back faces. So the length times the height is 18 and 7/10 times 8 and 4/10. Plus two groups of the sides would be the width, which is 2 and 3/10, and the height, which is 8 and 4/10. Now I'm leaving off all of the centimeters there just because I think it makes it crowded and a little bit more confusing, so I'll add the label back in at the end. So let's do 18 and 7/10 times 2 and 3/10. So we get 7 times 3 is 21, carry the 2. 8 times 3 is 24, plus 2 is 26. 3 times 1 is 3, plus 2 is 5. Put our 0 down onto the 2. 2 times 7 is 14, carry the 1. 2 times 8 is 16, plus 1 is 17. 2 times 1 is 2, plus 1 is 3. So if I add all of that together, and then I had two digits behind a decimal point, so 43 and 100th. And then I'm just going to go ahead and multiply that by 2. So we have 2 times 43 and 100th. Since I'm already at it, 2 digits behind the decimal point. So we get 86 and 200ths for this. Centimeters squared. So now let's do the plus 18 and 7/10 times 8 and 4/10. So 7 times 4 is 28. 8 times 4 is 32, plus 2 is 34, and 4 times 1 is 4, plus 3 is 7. Put the 0 down. 8 times 7 is 56. 8 times 8 is 64, plus 5 is 69. And 8 times 1 is 8, plus 6 is 14. And 2 digits behind the decimal point, so 157 and 800ths. So 2 groups of 157. Oh, I wrote that in the wrong class spot. And 8/10ths. So let's find what 2 groups of that is. So times 2. Two times 5 is 10, plus 1 is 11. 2 times 1 is 2, plus 1 is 3. So we get 2 digits behind the decimal point, so we get 314 and 1600ths. Plus, we need to do 2 groups of 2 and 3/10 times 8 and 4/10. Two digits behind the decimal point. So 19 and 3200ths. And 2 groups of that. So 38 and 6400ths. Let's add them together. I'm going to add 86 and 200ths to this. And then add the 38 and 6400ths. So we get 438 and 8200ths centimeters squared. Okay, oh good, fractions. All right, so let's do the top and bottom bases first. We'll have 2 groups of 2 1/3 times 2 1/3. Oh, but you notice it is a cube because all the side lengths are 2 1/3. So we can do the formula 6s squared. So 6, if you want to do the other formula, you'll get the same thing. So if you want to do the 2 times length times width times 2 times width times height and times 2 times length times height, you'll get the same thing. But this is a shortcut because all 6 sides are the same. So we can do 6 times one of the sides, 2 1/3 squared. So let's do 2 1/3 times 2 1/3. Figure out what 2 1/3 squared is. So 7/3 times 7/3 would be 7 times 7 is 49 ninths. 9 goes into 49. Let's see, 9 times 5 is 45. So we'd have 5 and 4 ninths left over. And we just need to do 6 times 5 and 4 ninths. And I'm just going to leave it as 49 ninths. And I'm going to do the box method because that's going to be a big improper fraction that I don't want to have to divide later. But you can do it a different way if you want. So 6 times 5 is 30. 6 times 4 ninths would be 24 ninths. And 9 goes into 24 twice because that's 18. 24 minus 18 would be 6 ninths, or 2 and 2/3. Add those together. 30 plus 2 and 2/3 would give us 32 and 2/3. So we would get 32 and 2/3 feet squared. So again, if you wanted to do this way and solve that whole formula, you will get 32 and 2/3. So either way you do it, if you want to take the shortcut and do the shorter formula, 32 and 2/3. If you want to take the long route, because that's what makes sense to you, go for it. You'll get 32 and 2/3. All right. More decimals. So two groups of, this is not a cube, so we're going to have to go back to the long formula. Let's do the top and bottom bases. So top is 32 and 3/10 times the width is 24 and 7/10 plus, let's do the front face and back face. 32 and 3/10 times 7 and 9/10 plus, then the sides are 24 and 7/10 times the height, 7 and 9/10. Okay, it's just a lot of math to do. This is more about just making sure that you don't go too fast, because just one wrong math fact and it's messed up your whole problem. So 32 and 3/10 times 24 and 7/10. Four times 3 is 12. 4 times 2 is 8, plus 1 is 9. 4 times 3 is 12. 2 zeros. On to the 2. 2 times 3 is 6. 2 times 2 is 4. 2 times 3 is 6. 2 plus 9 is 11. Plus 6 would be 17. That's 5 plus 4 is 9, and 7. 2 digits behind a decimal point, so we have 797 and 81/100ths. Plus, I'm just going to multiply that by 2, so that we're just one more step ahead. Okay, and 2 digits behind a decimal point, so 1,595 and 62/100ths meters squared. Plus, we're going to have two groups of 32 and 3/10 times 7 and 9/10. Nine times 2 is 18, plus 2 is 20. 9 times 3 is 27, plus 2 is 29. 7 times 3 is 21. 7 times 2 is 14, plus 2 is 16. 7 times 3 is 21, plus 1 is 22. And 2 digits behind the decimal point. So we have 255 and 17/100ths. Let's multiply it by 2, because there's 2 of them. Two digits behind a decimal point, so 510 and 34/100ths meters squared. And the last one, 24 and 7/10 times 7 and 9/10. 9 times 7 is 63. 9 times 4 is 36. Plus 6 will be 42. 9 times 2 is 18, plus 4 is 22. 7 times 7 is 49, carry the 4. 7 times 4 is 28, plus 4 is 32. 7 times 2 is 14, plus 3 is 17. And 2 digits behind a decimal point. So 195 and 13 hundredths, 2 groups of those. Let's just multiply it by 2 for the 2 faces. 1 times 9, 2 times 9 is 18, plus 1 is 19. 2 times 1 is 2, plus 1 is 3. 2 digits behind a decimal point, so 390 and 26 hundredths meters squared. Okay, add them all together. So I'm going to add 510 and 34 hundredths to this one. And then add 390 and 26 hundredths. Okay, 2,496 and 22 hundredths meters squared is the surface area. There we go. And you can always use a calculator to check to make sure that all of your math is correct. I would actually highly suggest that. Okay, number 5. Write a numerical expression to show how to calculate the surface area of the rectangular prism. Explain each part of the expression. So we're just going to write a numerical expression and explain each part. So 2 groups of, let's find the area of the bases. So 2 groups of 12 feet by 3 feet. So I'm just below it going to say that that is the area of the top and bottom bases. And then I'll do a different color for the next part. So plus, let's do the front and back faces. So 7 by 12, 2 groups of 7 feet by 12 feet. So that is the area of front and back faces. And then let's do the side faces. So the side faces would be 3 feet by the height is 7 feet, and there's 2 of them, plus 2 groups of 3 feet by 7 feet. So that's the area of right and left side, right and left side faces. Does it say we need to solve, write a numerical expression, how to calculate the surface area, explain each part? I think we did it. All right. Number 6. When Louis was calculating the surface area for problem 4, he identified the problem. So back up here to problem 4. He said the length is 24 and 7/10. So he identified this as the length. The height, or the width, is 32 and 3/10. So he said that's the width, and then he must have said that the height is 7 and 9/10. However, when Rocco was calculating, he said the length was 32 and 3/10. The width is 24 and 7/10. And the height is 7 and 9/10. So who's right? Would Louis and Rocco get the same answer? Why or why not? So I always calculate it like Rocco does, but it could have been possible that maybe Louis had it on a different side. So it doesn't really matter. As long as you calculate the right faces and the right areas for each face, it doesn't matter in what order you're doing them. So they would get the same answer because it doesn't matter. So let's say they would get the same answer. Because they are still finding the correct area of all 6 faces. So it doesn't matter, just because it's like the commutative property and associative property. It doesn't matter in what order we're multiplying them and adding them. As long as we've covered all 6 faces, it doesn't matter in what order we do that. Number 7. Examine the figure below. A. What is the most specific name of the 3-dimensional shape? All right, well, all sides are the same length, so, and it's 3-dimensional, it has 6 faces, so it's going to be a cube. Right, 2 different expressions for the surface area. So let's do the surface area of a cube first. So we could do 6 times one of the sides squared. So 7 by 7, 7 squared, would be equal to the surface area. So there's one formula. Or we could do the rectangular prism formula and do 2 groups of 7 by 7 plus 2 groups of 7 by 7 plus another 2 groups of 7 by 7. Either one is going to get you the same thing. Okay, let's explain how these 2 expressions are equivalent. So they're equivalent because the first one shows seven meters times 7 meters, or shows 7 meters squared, which is equal to 7 meters times 7 meters. So these 2 pieces are equal. Then the 6 represents the 6 faces, and we have 3 groups of 2 identical faces in the other expression. So the 2 groups and 2 groups and 2 groups of identical faces in the other expression is also equal to 6 faces. So that's why they're equivalent. So this 7 squared is equal to 7 times 7, and then the 6, we have 2 and 2 and 2, which adds up to 6.